Hi, in this video, we're going to talk about a special case where you have constant cash flow and constant discount rate, but it extends indefinitely into the future. So the cash flows will be repeating itself indefinitely. So how do we calculate the present value of such cash flows, right? So remember the annuity formula where we have C over R times 1 minus 1 over 1 plus R to the power of t. Okay, but here we don't have a specific t here, right? Because we said it's indefinitely into the future. So we only need to change a little bit here is by taking the limit of this value, but t approaches positive infinity. Okay, so it should be very straightforward here because as the exponential number here, if it's infinitely large, then the denominator is also infinitely large, and 1 over that would be close to 0. So this bit you can ignore. Okay, so 1 minus 0 is just 1. So simply put, the value is just C over R. Okay, so this sort of perpetual payment or perpetual cash flow is worth just C over R. So they're called perpetuities. Okay, but it only works when you have constant cash flows each year and you have the constant discount rate throughout the years. So if you have a change, even a slight change to the cash flows or to the discount rate somewhere in the time frame, you can't use this. Okay, then you cannot use the perpetuity formula. It only works with everything, with the cash flow and the discount rate is always constant. Okay, so what is the connection, or what is the how do we relate the perpetuity to the annuity here? Okay, so let's take a look at these two different perpetuities. Okay, so let's assume that the cash flows here are all the same as well, the cash flow C, and for the second perpetuity, you still have the same cash flow, it's always C, and you have the constant discount rate of R, and you have the same discount rate and also constant discount rate of R for the second perpetuity. Okay, so for the first one, it's pretty obvious that we have the value of C over R, right? Because it's always constant and you have the same discount rate throughout the years. So what about the second one? Because it doesn't start from year one here, right? It doesn't start here, but rather it starts here at year 4. So what does it mean if we just apply the C over R to the second perpetuity here? What is the value of C over R for the second perpetuity? That's the value from the perspective or from the standing point or from the time perspective of year 3. Yeah, so we're discounting everything back to year 3, not year 0. Okay, so if we want the value at the year 0, then what do? We need to further discount it 3 times. Yeah, or you should write this 1 over 1 plus R to the power of 3. Okay, so this is the true value at time 0, or the present value. If you forget to discount it 3 times back, then it's only the value at t equals 3. Okay, so let's take a look at the difference between the values here. If you minus this thing, yeah, so C over R minus C over R times 1 plus R, 1 over 1 plus R to the power of 3, what do we have? We basically have C over R, if you just collect the terms here, 1 minus 1 plus R to the power of 3, which is the annuity formula for an annuity that lasts for 3 years, which is exactly the space here. Or you can see it as the 3 payments that we're missing here, right? So if we have 1, 2, and 3 here, then we're missing, sort of the difference is those 3 missing payments of cash flows here. So this is the connection between the annuity and the perpetuity formula. So the annuity formula is basically 2 different perpetuities and taking the differences, and one that happens somewhere in the future. Okay, so t years in the future. So here you know the difference between the annuity and perpetuity and also their formulas. So you should be able to calculate any given perpetuity's value, so with specific numbers of cash flow and specific numbers of discount rate. And now you should have a deeper understanding between the annuity formula and the perpetuity formula, because the annuity formula is basically the difference between two perpetuities.